Hello everyone, and now we discuss Anova, that is analysis of variance in R software. Analysis of variance is an analytical method that allows for comparison of multiple samples. It is probably the most widely used of all the statistical methods and can be very powerful. Anova suggests the method looks at the variance comparing the variability between the samples to the variability within the samples. That is, we are going to determine the analysis of variance of the samples, and that method is useful to compare the variances between the samples as well as variances within the samples. And now the formula notation comes in handy, especially when you want to carry out the analysis of variance or a linear regression. And here we can understand that regression is also a linear model. And analysis of variance as a way of linear modeling, and here R software as a R function called LM, here you can look at that LM, that carry out a linear modeling, and it also carries we can also determine Anova, including Anova. And R function AOV is useful to calculate the Anova. And here we discuss one-way Anova, that is one-way analysis of variance. And here in R software we use the AOV command to carry out the analysis of variance, and it is a simplest form. You would have several samples to compare. We can take one or more number of samples at a time, and we can compare the variance of the samples. And we explain this part by taking a simple example problem in R software. So for that, first of all, you consider three numerical vectors x, y and z in the R software, given as an x is equals to c of 3, 4, 3, 5, 6 and 12. Similarly, y is equals to c of 6, 7, 8, 8, 9, 11. And z is another numerical vector we have defined as a c of 19, 3, 8, 8, 9, 11. Now, with these three numerical vectors, you just get the data frame in R software, and I am naming that as a is equals to data dot frame. This is a R command we use to get the data frame of the numerical vectors. So data dot frame of x, y, z, and by in the R console, by performing this, we can get an output data frame of these three vectors like this. And now let us go for the step 2 in case of Anova. And now we to run the command AOV, that is which provides an analysis of variance, we must have the data in different layout from the above example data, and which contains the column for each numerical sample. And with AOV command you require one response variable, and that is what we call it as a dependent variable, and one predicted variable that contains several levels of factor, and that is one independent variable. Predictor variable is also called as an independent variable, and here we have taken that character labels of x, y, z. And now to achieve this is required layout, you need to convert the data by using a stack command. Stack command, this is another important command in R software, that we can stack the data before running the analysis of variance. So here stack, STACK, that is a command used in R software in several ways, and it produces always the same results. a 2-column data frame. It always produces a 2-column data frame. And if the original data have a multiple numerical data vectors, then we can stack that data frame by using a stack command, and we can name the original data like follows. So at the R console, if suppose you have previously we defined a data frame, we obtained a data frame named by capital A, and we are stacking the same here, stack of capital A, and then the output you can look at in the R console like this, which is given as values, and under the two titles called values and IND. So that the same data frame we can obtain by means of, that means it provides that what are the variables assigned for X, what are the variables assigned for Y, as well as what are the values assigned for Z. That all comes under 2-column vector and in the R console by stacking that the given data frame. And here we can observe that output produces 2 columns. One is called as a values and other is called as an IND. And if you give the new stacked data frame any particular name, and you can then apply new names to these columns also. We can even rename the columns in the R software by using certain R command called the names. And now I have taken B, another variable, and we have assigned that by the stacking value of capital A. So B is equal to stack of capital A, and now we are naming the B with the help of name command. So names of B we have given as a C of count comma site. Now you can look at that in the R console, the titles of the columns have changed into count as well as a site. Previously it is given as a values and IND, and the same that you can look at, the column names have changed now. And here one thing we have to observe that always the data may not contain all the values, but it may contain some unavailable data also may be existing in the given data. So in such cases the NA items, NA that is an unavailable items, if there are existing in the data, that you have to omit such data, and that can be done by using a na.omit command in the R console. So we use the na.omit command for the stack data which we have stacked previously. So now I have taken B is equal to na.omit of stack of A, and again you can name that B similarly as previous by giving the titles count and site. And when we do this na.omit, it automatically eliminates any NA items provided in the data and is stacked in an appropriate manner. Now we can go for the step 3 in the case of analysis of variance. And in most cases like this, you want to keep all the samples, but you can select some of them and create a subset using the argument called select. Here the data may always contain one or more samples, but we require only if suppose we require any few number of samples from all the given samples, then we can use a particular argument or an R function called select, and we can give some instructions with the help of this select command that what are the variables, what are the samples you required from all the given samples. That is here in this to understand we can go for R console, and here once the stacked data if you have taken, and we are taking that into a particular variable called C is equal to, previously the names in the stack is an XYZ, and now we are selecting only 2 variables out of 3 xy, that is a subset we are considering from the total set, that is we have given in the R console as a C is equal to stack of A comma select is equal to C of X comma Y. So then if you do a summary command in the R console, then we can get an output as like this, that is values and the ind with a minimum value value for this data is 3 and x is 6. And here we are getting first QU, that is a first quantile, it is a 4.75, median value, mean value, third quartile value, as well as a maximum value. R software gives all the information about the data provided by us. And in this case, you create a new item for your stacked data, and you require only 2 of the samples, and you use the select instruction to name the columns required in the stacked data. That is, note that the selected samples must be in quotes. That is very important. You always use the quotes. And if you have transformed some NA items into the new data, once again, after even stacking that, you once again apply the na.omit command, and then you can eliminate the NA items in the new data. That is, here we can observe that in our console we have taken C is equal to na.omit of stack of A comma select is equal to C of x comma y. That is, out of 3 variables we are selecting only 2 variables x and y, and we are stacking that, and finally we are omitting all the NA items from that data. And now we can even once again look at the summary of this particular variable C, and by doing this part we can omit all the NA items. That means we are not transferring NA items into the new data. And we have to notice that in the output the headings are values and ind, which are not necessarily what you want actually. So you can change that by using the names, and we can get that column names as a count and site. That is, we can do that by using names of C is equals to C of count comma site. Then easily we can change the names of the, that is the headings of the columns. And once your data are in the right format, now you are ready to move to the carrying a analysis of variance. And in this step 4, finally we are applying an AOV command, that is a analysis of variance command in case of one-way analysis. And so once you have your data in appropriate manner, and then you can do the analysis of variance, that is a ANOVA test, by using a command AOV, and you use the formula notation to indicate which is response variable and which is a predicate variable, predictor variable. And by that, before going for that, let me take the summary of B, and here the output we obtained for the B as in the R console. You can observe that count and site with the minimum, first quartile, median, mean, third quartile, and the maximum value. And now here in this example you can see that you have a numerical vector as a response variable, which is we are named it as a count, and the predicted variable is a site, and comprising the 3 levels in that, which are x, y, and z. And this kind of analysis where you have a single predicted variable, which is called as an one-way analysis. That means even if you have taken more number of predicted variables, then we can go for the two-way analysis. Okay, and here we are not discussing that, we are just only considering one-way ANOVA. And to get this required result, finally we take a variable D, and we are performing an analysis of variance for our data by the R command called AOV. So D is equal to AOV of count. That symbol you can look at that. This is what we call it as a tilde in mathematics. Count tilde site comma data is equals to B, and which we have previously stacked, and we have omitted that NA items, everything, and now we are performing analysis of variance for this, and we are obtaining the D value. And finally you can look at the output of this in the R command. And here we get a call, the AOV, and it is given by a formula. That formula is equals to count. Count is taken at the left hand side. You can observe that a tilde site. So here this count represents the response variable, and site represents a predicted variable. That means count is a dependent variable, and site is an independent variable, and the data we have taken is B. And here we can observe that sum of the squares, degrees of freedom, and residual standard error, all the values for site as well as residuals are given in the R console. And estimated effects may be unbalanced, and this gives you some information. But to see the classic ANOVA table of results, you need to use the summary command. And finally, if you get the summary command for the data D, where we have applied the ANOVA, we get a final output of analysis of variance in the R console for the predicted variable site. That is given degrees of freedom, sum of the squares, mean squares, F value, and the F value, that is a predicted F value. So along with the residuals means nothing but the errors. And here you can see the calculated F value and overall significance. Thank you very much.